Hi everyone and welcome back. This is part 2 of simplifying rational exponents. In the first video we went over the first page, select problems from that. Now we're going over the second page in this video. Quick reminder, these are some of the main principles we've applied to these problems. We primarily use these two in the first page, but now we need to be aware of this one. When we're dividing like bases with different exponents, we subtract the exponents from each other. We're going to use that a lot in these coming problems. Let's take a look at number 13. We have 2x to the negative 7 over 4th power over 4 times x to the 4/3 power. What do we do here? It looks really complicated, and it's not too bad, but we have to simplify it, okay? I always like starting with the coefficients. If the coefficients don't have parentheses with something outside, okay, and they don't have their own power, that means this does not apply to number 2, okay? Same thing with the denominator, is this 4/3 is not affecting that 4, so we can just simplify. We could rewrite it even as 2 over 4 times x to the negative 7 over 4 over x to the 4/3. We could do that, okay? And then this is easier to see that it simplifies to 1 over 2. Okay, we could cancel this with that and write a 2. And that would be pretty simple, and then we're ready to move on to a little bit tougher part. Now, how do we do this next part? Well, they both have a common base of x, so we can rewrite this expression. Okay, keep in mind we still have that 1 over 2 times x, and then we take our top number, our top exponent, negative 7 over, what was my setting at? I'm going to make it a little bit smaller. There we go. Negative 7 over 4 minus, because it's divide, okay, this is the same thing as divide, minus 4 over 3. Now I just have to worry about subtracting these exponents from each other. This gets to our fraction rules. How do we subtract fractions? Well, we need to have a common denominator. So I have minus 7 over 4 minus 4 over, oops, not 3. I mean, not 4, 3. The common denominator is going to be 12. The least common denominator between 4 and 3 is 12. They both are factors of 12. That's the smallest number. They both go in 2. So we're going to put, oops, we want it to be 12. So we're going to get that 4 to a 12. We have to multiply top and bottom by 3. This one we have to multiply top and bottom by 4. Quick review of fractions. If you need more help, check out some of my other videos. Bottom line is we have negative 21 over 12 minus 16 over 12. Now they have a common denominator, and we can simply put the common denominator, 12, and we have negative 21 minus 16. That is negative 37. Right. Okay, so now we have negative 37 over 12. 1/2 times x to the negative 37 over 12 power. We should really put that in the denominator. So if it's already 1 over 2, 1's in the numerator, 2 is in the denominator, and because this is negative, this gets rewritten as 1 over x to the 37 over 12 power. So that can go in the denominator with the 2, x to the 37 over 12 power. And there's our final answer. Looks pretty ugly, but it's just because we have some weird fractions being combined there. Right, so let's move on to number 15. 15 looks like it's super complicated. It's really not that bad. Always start, in my opinion, I think this is the best way to go, with the coefficients. Try to reduce some of the clutter. First, are there any coefficients that have an exponent applied to them? And the case is no. There's no parentheses here. There's no exponent right next to it. Okay, so the coefficients are pretty much set. Now, what we can do here is we can cross off the 3 with the 3. You see it in the top and bottom. You can cross it off because it's equal to 1. And 1 is an identity property when you multiply it. So now we have 3. And now we have the rest of the gang. Negative 1/2 for x times x to the 1/2 times y to the negative 1 over 3 over y to the negative 7 over 4. Take it step by step. First, can you simplify either the top or the bottom by itself? Can you simplify it any further before we start getting into the division and splitting it and subtracting and all that stuff? And the answer is yes. See, we have an x and the x in the top. That's this first rule we used on the first page. If you have like bases multiplying, you add the exponents together. What happens when we add x to the negative 1/2, and you add these two exponents, x to the negative 1/2 plus 1/2. Well, that's equal to x to the 0. That's equal to 1. Okay, so that's my little side note here. So we're going to say this is equal to 3, and then times 1. I'm going to write times 1, even though I'm going to get rid of it later. And then I have times y to the negative 1/3 that I still need to take care of over y to the negative 7/4. Okay, now we need to simplify these y's. Now, if there's division, that means we're subtracting the exponent. So we have y to the negative 1/3 minus a negative 7/4. That gets tricky when you have a minus minus, okay? This means divide. Okay, when you have a fraction. So if we're dividing, we're subtracting powers. Y to the negative 1/3 minus 7/4. Y to the, now we have to have a common denominator. And first I'm going to change it to plus. I don't like it when it's minus minus like that. So I'm going to change it to plus. And then we're going to have a common denominator of 12 again. So I multiply the top and bottom by 4 for 1/3. Negative 4/12. Plus, I multiply top and bottom by 3. 21/12. That's equal to y, was that 17/12. Now, what does that mean? That means it's going to be in the numerator. Notice how we had this negative exponent, and it ended up in the denominator. Okay, went from negative exponent to in the denominator. If it's a positive exponent, that means it's going to stay in the numerator. So y 17/12. When we write everything, let's choose like red for our color, or pink. I'm going to have 3 in the numerator, y to the 17/12 power, and it's over 1. This essentially gets combined with this, and there's nothing left in the denominator, so this is our final answer there. Okay, so it's not as bad as you might think. We're going to do 2 more problems. One is this guy right here, number 19. Notice how both the top and bottom are getting raised to the power. And then 22, we're going to do, usually the last one's the toughest. We'll see if it's an exception over there. Now, a couple things going on here. We have a lot of fractions, you'll notice. A lot of fractions. We have some negative exponents. And then we have everything being raised to the 4th power. Usually it makes sense to simplify the numerator, simplify the denominator first, and then raise it to the 4th power. In this case, though, I'm looking ahead. I can erase all of these and multiply using the exponent powers rule. I can multiply all the exponents by 4. There's an implied 1 there, by 4, and that will change how everything looks right away. Why would I do that? Because I know that I don't like to deal with fractions. And if I multiply by 4, a lot of those fractions are going to disappear. Let me demonstrate. First, let me choose a color here. I'm going to choose green for my x's, and I'm going to choose purple for my y's. Let's start with my x's. I'm going to apply, like I said, this 4 inside the parentheses first to each one of these multiplied variables. So I'm going to have x to the 1/2, and then I'm multiplying or raising this to the 4th power, which means I'm going to raise the power, or I'm going to multiply the power, sorry. Then I have y to the negative 2, and I'm going to raise this to the 4th power, which means I'm going to multiply the powers. Okay, I hope you guys, I'm being very explicit here, but I hope you get what I'm trying to do. Then I have y to the 1st power. I'm not sure why it's written first, but I'm raising this to the 4th power. And then I have x to the negative 7/4, and that's raised to the 4th power. Okay, now, what happens here? Well, I multiply the powers, because that's the powers rule. Okay, multiply those powers, multiply those, multiply those, multiply those. And the whole point was I looked ahead and I was like, you know what? It's going to make my life a lot easier if I get rid of these fractions. So I have x, 1/2 times 4 equals 2. Okay, so now I have no more fractions. That's great for us. Y equals negative 2 times 4, negative 8. We can handle that later. Y to the 4th, 1 times 4 is 4. Okay, that's an implied 1 there. You could just see if you wanted y to the 4th power is y to the 4th. Okay, you get it. Now I have x, and then I have negative 7/4 times 4 is just negative 7. This is much easier to deal with than what we were working with before. Okay, now this becomes a pretty simple problem where I have division here. So now I'm going to subtract powers. This division means I'm going to subtract powers. So I have 2 minus a negative 7 for my x. And then I have y to the negative 8 minus 4. Let's simplify this further. We have y to the 2 minus negative 7 is 2 plus 7. That's 9. Why did I change it to y? I meant x. And then y to the negative 12. As I write my final answer, I need to convert this negative into a positive exponent by moving it to the denominator. So this is x to the 9th over y to the 12th. That's my final answer. So all of this ends up being just that. Pretty cool, I think. So now we're on to our last problem, number 22. Let's take a quick peek at this. I don't think there's any avoiding fractions here, especially here we have fraction being multiplied by this. It's going to make this one easier. So I guess what we're going to do is we're going to simplify the bottom and the top separately and then go from there. I'm actually going to start from the bottom. So over here I'm going to handle these guys first. Let me go ahead and show that down here. Okay. I was using, I think, green for the x's. Let's keep that pattern, and then purple for the y's. We'll keep that pattern. I like that distinguishing feature. Now, when we have multiplied like bases, we add exponents. So we're going to have x to the 2/3. The other like base is x right here. So I'm going to add that exponent plus a negative 3 over 2. For my y, I'm going to have y to the 3/2 plus, because it's multiplied, 1/2. Okay, that one's pretty easy. So let's start with the y. We have 3/2 plus 1/2. That's 4/2, aka y equals 2. Or y is not y equals 2. Y to the 2nd power. This guy in green, the x's, I need to find a common denominator. So this is going to change to x to the common denominator 6. So that's, 4 over 6. Minus, plus and minus, the same thing as minus. Minus, I multiply that by 3, so that's 9 over 6. That's going to be x to the negative 5 over 6 times y to the 2nd, okay? So I have my denominator. I'm going to write it in pink. X to the negative 5 over 6, y to the 2nd. Okay, I started from the bottom. Now I'm here in the numerator. Let's use blue. Okay, so we're going to simplify this guy. This guy gets simplified. Well, we're going to distribute, essentially, this. We're going to raise each one of these to the 1/4 power. We call x to the negative 1/2 times 1 over 4. And then we have y to the 4th times 1 over 4th. The y to the 4th times 1/4. Again, the y is the easier of the two. We're going to get y to the 1st power. And then we have the tough one, which is x to the negative 1 over 8. Okay, the y's. Let's go to the y's again. Let's change it to purple. Where this is going to become y to the 1 minus 2, because this is division, and when you have like bases dividing, you subtract the exponents. We're going to go to the green. The green is going to be the x's. We have x to the negative 1 over 8 minus a negative 5 over 6. And we can simplify the y's pretty easily. That's going to be y equals, why do I keep saying that? Y to the negative 1 power. The green is going to be a little tougher. We have to have a common denominator again. I think the smallest one is 24. So we multiply 8 by 3 to get 24. And this is going to be plus, because it's minus minus here. Plus, and then we multiply 6 by 4, so that's plus 20 over 24, which yields us 17 over 24. So that's x to the 17 over 24th power, y to the negative 1. Let's rewrite that with positive exponents only. X to the 17th power over 24 over y to the 1st power, just y, and that's our final answer. It's amazing how much it can be simplified if you take it step by step. I hope you learned something in this video. I hope you enjoyed it. If you want more, or if you want something else covered, let me know in a comment. Let me know what you need. I'm here for you. I enjoy making these videos. I hope you guys enjoy watching them, and I hope to see you next time on Wes Explains Best.